Hi guys, Dr. Diaz here again. If you remember, the last problem that we working with concave mirror was the one in which the image was exactly in the focus. I mean, the object was exactly in the focus. And you remember that occasion, a line where right there goes parallel to the optical axis. When it hit the mirror, it will go to the focus. And the other one we said is the one that goes exactly at the center of the optical axis. When it bounces back, it will go all the way and it will be parallel to this one. They will never intersect. Another one that they, like in this picture throw in, they go for the center curvature, it hit the object. When it hit here, the mirror, it bounces back, it goes in the same position, and you can see that this way, and the other one that I will be making, something like goes like this. One that goes here, well, this thing is capable to write. I'll show something there. Hit the mirror, they will go parallel, and then you will have all these three rays. This one should go something like this. Yeah, because then this angle and this angle is the same by the law of reflection, and they never intersect. Well, if they intersect, theoretically they would meet at infinite, but the image, if I want an infinite, you cannot see it. Alright, but this was the one we did in last class. Now we're going to another case. Okay, now we have here the case in which the object, and I'm not sure you can see this blue arrow here, is between the focus and the mirror. So the same thing we used to do before. We're going to trace a ray that it goes for the focus. Well, actually, first the one that goes parallel to the optical axis. When it hit the mirror, it will converge to the focus, right? So let's do that one. Okay, here we can see that a ray that it goes parallel to the optical axis. When it hit the mirror, it will go to the focus. Now you will start wondering why I draw those dotted lines. Of course, you would know what's going to happen in a second. The other one, it would be the one that it goes to the focus. Well, unfortunately, that will go in parallel to the optical axis. It's actually the same ray, so we have to choose another ray for this one, and that will be going from the focus to the image, to the mirror, and then going parallel to the optical axis. Something like this. I'm going to draw it now. Like this. A ray that it goes through the focus, when it hit the mirror, it will go parallel to the optical axis. I'm using now this grid here. A ray that it goes parallel, it goes through the focus and it hit the mirror, it will bounce back parallel to the optical axis. But as you can see, none of these rays are going to intersect, which means the image is not forming at this side of the mirror. If we go the other way around, this way, and you do the dotted lines, look what's going on here. What happened here? The lines converge, and that means that here is where the image is forming. Here, let me get rid of the grid. Here is where the image is forming. Not in the what we call the real size of the image, the mirror. It will be in the inside the mirror, which means that this image is characteristic. Look at the characteristics. Let me change the color of this thing. Well, first one is real or virtual, because the image is formed inside the mirror, and there's no way you can go measure its distance unless we use the focal length equation. This image is actually virtual because it's formed inside the mirror. Second is upward or erect. I don't like that word, but that's okay. And the last one is bigger. So this is a case in which the image is virtual. It's formed inside the mirror. You don't see the other side because you see this ray. Well, first one, this one, it goes parallel to the optical axis. When it bounces, it goes in this direction. And the other one, it goes to the focus. When it goes in this direction, it bounces back, it goes parallel to the optical axis. And you can see that these two rays never converge. But if you go this ray, move backward. And this ray, instead of bouncing, in this one, instead of bouncing this way, keep going up, like from the focus going up, you will see that here is where those rays intersect, and the image is going to be forming here is a virtual image, which is much bigger and is upward. It's upward. And here is a picture of this case, right? An image that is between the mirror and the focus, a smaller distance than the focal point, and look what happened. This ray goes here parallel to the optical axis. When it hit the mirror, goes to the focus. And this one this one used the one from the center of curvature, which is another one, and still is forming there. The one we were saying will be from the focus, hitting the mirror, hitting the object, goes to the mirror, and then parallel to the optical axis. It should go this way, but in this case, it's going that way, and both will intersect. Both will intersect at the same point. Here. Yep. Yes, this is a case of concave mirror, but it's what the image is between the focal length and the mirror. We're going to do now the convex mirrors in a second. Okay, guys, now we have here the case of a convex mirror, and the same goes as before. A ray that goes parallel to the optical axis, when it hit the mirror, it will not go to the focus. In this case, it will bounce off and goes to the other direction. But if you look this ray bouncing off this way, going here parallel to the optical axis, it bounces off because of the way the mirror is. If you move backward, it seems that this one, it will be intersecting here. It's like the projection of the focus here being somewhere around here. Yeah, that's it. Yeah, that's it. Somewhere around here. It's like there's another focus here. If this is a focus, you will see there will be another one, call it F prime, sort of whatever, inside of the mirror. And that's what's going to happen. And then we throw one that it will go, let's say, pointing at the direction of that focal length in this direction, and you will see that in that case, these two rays will intersect. Let's do that in a second with ray tracing. Okay, you can say here and see here that a ray that it goes parallel to the optical axis, when it hit the mirror, instead of going in this direction, which actually it will be the same. If it goes in this direction, it will be the angle here, angle here will be the same by the law of reflection. But because it's convex, the image goes the other way, bouncing off. Or you can think about it, what if it goes in the other direction of the, let's say, virtual focus or something like that? That's an interesting one. Because the next ray, when it goes here, pointing in the direction of the focus, you know what's going to happen. I'm going to show you now. Now look here, a ray that it goes up, pointing basically at the focus. Here, this one. When it hit the mirror, it will go parallel to the optical axis, right? So look at this one. This one, the first ray goes parallel to the optical axis, and we would think it would go pointing at the focus. When in reality, now it's bouncing back, but it actually somehow is pointing at the direction of that virtual focus. And one that it goes pointing at the focus, when it hit the mirror, it will go parallel to the optical axis, which means that the point in which these two rays converge here is where the image is being formed. And you can see here characteristics. Look at this one. First, is real or virtual? It's virtual. Second, is upward or downward? It's upward. It's virtual. It's upward. This is forming inside the mirror. And third, is smaller. Yeah, the one we saw a moment ago was bigger. In this case, when the image was between the focal point and the mirror, in this case, for a convex mirror, it's going to be smaller. And actually, some of you already experienced this when you go to those stores that they have these convex mirror there, and well, you have better field view, but the objects or the people looks like kind of smaller. Yeah, that's it. That's exactly the purpose, to have a better field view and see everyone, basically. Okay, guys, I think this is all for mirrors. Later on we'll discuss lens. I hope this helped a little bit. Oh, let me show you something else before we go. And voila, another picture. Figure that it shows what we're doing here, right? Look here, the object, a ray that it goes parallel to the optical axis, it bounces off, but it actually will look like it's pointing at this at the focal point. And look at this one. This is another ray. A ray that it goes looking to the center of curvature. It bounces back and it will go there. It is actually similar to the one that I was saying, looking at the focus, and when it hit the mirror, it goes parallel to the optical axis, and all those three rays will converge at the same point, and where you're gonna have here the image being formed. And look what happens. What is formed the image? Well, it says here behind the mirror, is basically inside the mirror. It's virtual, it's upright, and is smaller. Okay, guys. So I hope this helped. Take care. See you next time.